I'm currently seeking the business analysis certificate. I recently got the intelligence certificate, and I have my BS in statistics several years ago. I'm doing my analysis on college football statistics and the most relevant statistics that create a winning season. To predict a winning season from team statistics, I wanted to keep the model as simple as possible. I wanted to avoid misclassification, and I wanted to limit the input variables. But when I was gathering my data from sportsreference.com, I noticed that they break down every single thing that can happen on a football field. So the statistics are in many different categories and in many different spots. So on Sports Reference, I gathered the offensive, the defensive, and the kicking statistics for each team, FBS Division I team, from the year 2000 to 2014, which resulted in a observation set of 1,930 with 77 variables. So I wanted to try to predict the college football bowl eligibility, which is basically having a winning season, with the most accuracy. So I basically threw everything in to the predictive model into Enterprise Miner, and Enterprise Miner has great predictability. It is very powerful software, and so it can come up with a model that will predict whatever you feed it. With that being said, I know that the last slide, the diagram, was very hard to read. So my summary is I basically use 3 different modeling methods. Decision tree with the chi-square probability as a nominal target, the decision tree with the Gini statistic as a nominal target, and regression analysis. And I run each one of those modeling methods through 4 different flow paths: clustering alone, variable selection and clustering, variable transformation, and clustering, as well as variable binning. So that's why all of this looks cluttered, but it also gives us many different aspects of modeling, and it produces a great model. It predicts the validation set to 99%. But all the modeling showed, when I combined the offensive, defensive statistics and the kicking, was that defensive points allowed, negative correlated, extra points attempted, positively correlated, and it created this dummy variable of group games, classified group variable, with some games being played less and some games being played more, and they were both positively correlated. But basically, in essence, you would go to the coaches and be like, all you have to do to win is allow less points and kick more extra points. I don't think that's very helpful. So then we went back to the drawing board. This shows, though, with Enterprise Miner, with any modeling software of this capability, there are many out there. If you put garbage in, or if you put everything in, and you don't know what you're processing, what you're trying to achieve, the questions that you're trying to answer, if you put garbage in, you're going to get garbage out. I've heard many of my statistics professors and analysts go over this and say the same cliche saying, garbage in, garbage out. So the academic program here teaches us that we have to properly evaluate and clean the data, and that is the first step before you can do anything with the data to actually get interpretable and meaningful models. So I revisited the data. I removed the additional statistics, strength of schedule, the rating systems, the statistics that were mathematical formulas of other statistics, because SAS can interpret all of that. It doesn't need to calculate a percentage. It doesn't need to have percentage in and then also have the variables in. So I did that, and I kept only the variables that coaches can actually evaluate on and practice and teach. Then I also run the model through variable selection, and I normalized the variables to come up with a different model and a new ROC curve, which was presenting representing or accurately predicting about 83% of games, but it also had meaning. The parameter estimates are things that coaches can teach. Limiting or trying to go after defensive interceptions, trying to force other teams into more pass attempts, which means they're in longer yardage situations, not advancing down the field. Limiting the defensive rushing yards. I also run a variable of importance on the most identified variables, and defensive rushing yards was the #1 most important variable in trying to predict winning seasons. There are a few others here. Offensive rushing touchdowns, actually capturing defensive interceptions, performing offensive interceptions, all good variables for detecting winning seasons. So now we can draw some actual conclusions. Defensive rushing yards, interceptions, punting the ball, and defensive passing yards obviously inversely correlated with winning seasons. Offensive rushing touchdowns, defensive interceptions, punt return attempts, and defensive passing attempts positively correlated. Those were the meaningful variables that come out of the model. So we try to limit the inversely correlated and try to maximize the positively correlated. These are things that you can take to coaches and actually they can practice on and work on for creating a team that will have a winning season. It also brought up across 2 cliche sayings that I've been around and had coaches tell me all my life, and now I can statistically prove it. Conclusion, the first factor, stopping the run, wins more football games. Also being on the positive side of the turnover, the interception turnover factor. And the second one was defense wins championships. Thank you very much.